Special circulation. So what are these special circulations and what they are special? First of all, what is normal circulation? Normal circulation is when we have the artery. It gets to the tiny capillaries, and then those capillaries combines into veins. Yes, then they get to bigger veins. We start from big arteries and so on. So now good question. What are the special circulations? Let's start, for example, from the kidneys. What is special about kidneys? In kidneys, it started as usual. So we start from arteries, then we get the capillaries, but then we have arteries one more time. And this is strange. Yes? So we have arteries, capillaries, and veins. So this is not as it should be. This is different. Generally, these capillaries that are here, so between arteries, are responsible for filtration. So this kind of system leads to higher blood pressure in these capillaries and leads to filtering of the urine faster and more efficiently. That's why it is so. Okay, so now different example. How it is in the splanchnic, so about the liver. I will get to the details in a moment. I will just draw it first. Okay, so now you see something different. Now you see we have arteries, capillaries, veins. Where is it and why it is so? First of all, we have some arteries, like everywhere, we need to supply the blood. Then, where this blood supply gets? In this case, it gets to the intestines. In those capillaries, we have absorption of nutrients, vitamins, things like that. So a lot of important stuff, but toxins also. So then it gets through the splanchnic vein to the liver, and then in the liver, this blood needs to be filtered. Yes, all of the toxins need to be detoxified. Nutrients need to be processed. So, for example, some vitamins needs to be stored, some lipids needs to be processed into the LDL or HDL. And so on. So we need this processing, and in order to enable this processing, we are getting veins into sinuses, and then through the hepatic veins it gets to the big circulation. So this is how it is in the splanchnic circulation generally. What else do we have? We also have something interesting in case of the muscles. In case of the muscles, there is some ability to increase the blood flow just before even the exercises started. Yes, so some neurological impulses already shows us that some exercises will happen, so it increases the blood supply to the muscles even before the exercises begin. What else? We have also skin. In case of the skin, you observe it for sure a couple times in your life at least, that when we are in cold places, our skin gets pale. When it's hot, our skin gets red. Why it's pale or why it's red? It's red when there is a bigger amount of blood. It's pale when there is smaller amount of blood. In this area, in the skin. So increasing the blood supply to the skin will increase exchange of the temperature with outside world. Decreasing amount of blood that gets to the skin will decrease the exchange of the temperature with outside world. So when it's cold, we do not want to get heat out. Yes, we want to keep it in the inside of the body. So we are decreasing the blood flow through the skin. When we want to radiate the heat, it leads to increasing blood flow through the skin. Simple like that. Okay. Now, very important, heart. So heart is like another muscle in some extents. So let's get a cross section of the heart. Yes, this is the heart muscle, and this is inside of the heart. Yes. So as you imagine, heart is relatively thick muscle, and in order to supply the blood into the heart, we need to get the arteries, obviously, because the blood from the inside of the heart, so from here, would give blood only to the very, very thin layer of the heart muscle, mainly to the endothelium. In order to supply the muscle of the heart, we need the coronary arteries. And the coronary arteries has some big problem. Imagine that this muscle is squeezing and unsqueezing all the time. So when it squeezes and it has some artery, imagine the artery in this spot. Yes, let's make it green just to make it visible. So imagine this green artery. What is happening with this when this muscle would squeeze? When this muscle would squeeze, it will lead to squeezing of this artery also. And this is a problem. So squeezing of this artery will reduce the flow through this artery. And it leads to the problem that less of the blood would reach the heart muscle and less of the blood would be available for heart muscle. And it may lead, even in some cases, to the heart attack. However, of course, this is a normal situation. Not good, but normal situation that the arteries are squeezed during every contraction of the heart muscle. So we have some mechanism of the compensation, and usually nothing happens because, as you know, you are living, and we are living. But it shows us that most of the blood flow through the heart is happening not during muscle contraction of the heart. Yes, because during the muscle contraction, the arteries are squeezed too much. And this is very important, just to remember. Okay. And now brain. So what is happening in the brain? What is different than in the rest of the body? Generally, brain is called to be autoregulated. What does it mean? It means that extrinsic regulation of the blood supply that we were talking about last time is not affecting brain too much. Yes, so it's autonomous, we can say. The main thing that is regulating how much of the blood would get to the brain is carbon dioxide levels. So if there is too much of the carbon dioxide, it means that we need more blood. Simple like that. So the carbon dioxide levels are the most important thing that regulate the amount of blood that flows through the brain. Okay, I suppose it's enough. Thank you very much.